In numerical linear algebra, the Jacobi method is an algorithm for determining the solutions of a diagonally dominant system of linear equations. Each diagonal element is solved for, and an approximate value is plugged in. The process is then iterated until it converges. This algorithm is a stripped-down version of the Jacobi transformation method of matrix diagonalization. The method is named after Carl Gustav Jacob Jacobi. Description: given a square system of n linear equations, where then A can be decomposed into a diagonal component D, and the remainder R. The solution is then obtained iteratively via the element-based formula is thus: the computation of xi, k plus 1, requires each element in X, k, except itself. Unlike the Gauss-Euler method, we can't overwrite xi, k, with xi, k plus 1, as that value will be needed by the rest of the computation. The minimum amount of storage is 2 vectors of size n. Algorithm: choose an initial guess to the solution. While convergence not reached do, for IA equals 1 step until n do. For J equals 1 step until n do, if J a permil I then end if end check if convergence is reached. Loop convergence: the standard convergence condition is when the spectral radius of the iteration matrix is less than 1. The method is guaranteed to converge if the matrix A is strictly or irreducibly diagonally dominant. Strict row diagonal dominance means that for each row, the absolute value of the diagonal term is greater than the sum of absolute values of other terms. The Jacobi method sometimes converges even if these conditions are not satisfied. Example: a linear system of the form with initial estimate is given by. We use the equation, described above, to estimate. First, we rewrite the equation in a more convenient form, where and. Note that where and are the strictly lower and upper parts of. From the known values, we determine as. Further, C is found as. With T and C calculated, we estimate as. The next iteration yields. This process is repeated until convergence. The solution after 25 iterations is. Another example: suppose we are given the following linear system. Suppose we choose as the initial approximation, then the first approximate solution is given by. Using the approximations obtained, the iterative procedure is repeated until the desired accuracy has been reached. The following are the approximated solutions after 5 iterations. The exact solution of the system is. An example using Python 3 and NumPy, the following numerical procedure simply iterates to produce the solution vector. Produces the output. Weighted Jacobi method: the weighted Jacobi iteration uses a parameter to compute the iteration as, with being the usual choice. Recent developments: in 2014, a refinement of the algorithm, called scheduled relaxation Jacobi method, was published. The new method is alleged to provide a 200-fold performance improvement. See also, Gauss-Euler method, successive over-relaxation, iterative method. Linear systems, Gaussian belief propagation, matrix splitting, references. External links: this article incorporates text from the article Jacobi Method on CFD Wiki that is under the GFDL license. Black, Noel. Moore, Shirley. And Westerstein, Eric W., Jacobi Method, MathWorld. Jacobi Method from www.math-linux.com, Module for Jacobi and Gauss-Euler iteration, numerical matrix inversion.